this is a question to ask you to calculate the pH of a buffer solution. That buffer is made from a weak acid, HClO, okay, with its conjugate base. So if I have to write an equation to show the dissociation of this weak acid, it will look like this: ClO negative and H plus. So this is the acid and this is the conjugate base. Okay, now there are many steps in making this buffer solution. First, they dissolve chlorine in water. So the total volume of that solution is 1000. So let me put it here first, volume. So we are going to need this volume to calculate the concentration later. So chlorine is dissolved in water to produce a solution containing 0.107 mole of this HClO acid, and also we have 0.170 mole of HCl formed. Okay, this H plus with the Cl minus will form HCl. Okay, and to prepare a buffer solution, 0.2 mole of sodium hydroxide is added to this solution. Okay, the added solid sodium hydroxide, so volume, the total volume not change, still 1000. Okay, now sodium hydroxide will react with both the HCl and also this HClO weak acid. Yeah, it will react with both. NaOH will react with HCl, will also react with the weak acid HClO. So I get NaClO and also H2O. Now for both neutralization, 1:1 mole ratio in both the equations. Okay. Now we can start to work on how to calculate the pH of the buffer solution. First thing that we need to do is I want to find out how much, okay, how much NaOH is used to react with hydrochloric acid. Okay, hydrochloric acid is 0.170 mole. 0.17, okay, let me write here. NHCl is 0.170 mole. Since this equation shows us that 1 mole of sodium hydroxide will react with 1 mole of HCl, so the number of mole of NaOH reacted with HCl is 0.170 mole. Because they added 0.2, right? So sodium hydroxide is actually in excess. After reacted with HCl, we still have NaOH. Remaining NaOH, okay, after reaction with HCl, which is 0.2 minus 0.170, so 0.030 mole. Now this 0.030 mole of sodium hydroxide will then react, okay, look at the second equation, will then react with our weak acid. Okay, 1:1 mole ratio also, so the number of mole of the weak acid reacted with NaOH is 0.030 mole. Okay, number of mole of the weak acid remaining will be 0.170 minus 0.03. Okay, why? Okay, we start with this amount of the weak acid. So I should get 0.140 mole of HClO in the solution. So now the buffer solution that is formed, okay, the number of mole of HClO will be 0.140 mole. Okay, the base will be 0.03. Now, how do I know the amount of base that is formed? Okay, it is from this equation 2 also. The number of mole of NaOH, okay, was reacted with weak acid is the number of mole of base that is formed in the buffer solution. So 0.30, this one. Okay, and from here and from here. Right, these two reacted with each other and we get the same number of mole of the conjugate base salt. Now I have the number of moles now for the acid and also for the base. I can calculate the pH of the buffer solution by using this formula. pH equals to pKa plus the logarithm of concentration of the base, okay, over the concentration of the acid. So Ka is given here. pKa is negative log Ka, 2.9 times 10 to the power of negative 8, plus log the concentration of base. Concentration of base is 0.03 mole divided by total volume. Concentration is number of mole divided by volume. And then concentration of acid will be 0.140 divided by the total volume. You can see that we can cancel out the volume actually. So you will be able to find the pH value of this buffer solution, okay, which is 6.87.